All right, everyone. So welcome to our first KI Park Tech Talk in 2023. Last year, we had about 8 tech talks already, which were all inspiring, and I'm very happy to kick it off today in 2023. This is our first tech talk. My name is Mark Karahan, and I'm a venture development lead at KI Park. Our tech talks really take you to the center of AI, and we regularly invite experts to discuss recent developments in tech, to inspire by showcasing AI use cases, and to share insights when developing and applying AI. So before introducing our topic today, and before also welcoming our expert of today's Tech Talk, I would like to give you a short overview about KI Park, a short intro for all of those of you who are first-time listeners and who have just joined us. Yeah. So, what is KI Park? KI Park's mission is really to accelerate AI innovations. We are an ecosystem about 70 and maybe more even in the recent days of corporate startups, research organizations, and NGO who all are come together in that ecosystem in order to push AI to the next level and to really strengthen Europe as a tech hub, strengthen Germany, and bring it to the upfront noise to really create that awareness of AI innovations and what's possible. So our ecosystem, as you see by the logos, covers various industries and thematic clusters. We have mobility involved, we have healthcare involved, we have robotics, we have quantum, we have a lot of machine learning knowledge in this network, and really creating that atmosphere and expertise in here where collaboration is at the center in order to push AI. We support our members and also society with various activities. We are an NGO that really has AI at its core mission. So we enable new connections by uniting all tech enthusiasts, if you will, be it developers, founders, regulators, and decision makers. We also enable new projects and new partnerships that are there to build the next generation of AI innovations. And we bring to society the attention to AI by providing a stage to experts to inspire about the opportunities that arise from new tech, such as this tech talks where we are discussing just like new phenomenon and recent developments. We also create that environment for accelerating AI innovations, bringing it into actions by providing infrastructure, by also providing space involved. And really that creates a whole package for companies that want to engage in AI, that develop AI to flourish and to boost their own activities, to get more awareness and to get new connections involved. At the very end, I will also share some links with you if you'd like to learn more about us. But today, first of all, we start today with our tech talk. And I'm very happy to welcome Angela Maennel from dida today. Angela works as a machine learning scientist at dida Datenschmiede, where she leads various ML projects. Most of her recent work focused on NLP, however, which she's applying in customer projects and where she's really using it in order to solve client needs. And prior to that, Angela has a background in mathematics at ETH Zurich. So get ready and be prepared for some really nerd things going on today. She will share her insights from an NLP project that she applied. And the topic of today's talk is understanding customer needs with NLP. Before we start and before I hand over to Angela, two more things. First is an information to you. This tech talk is going to be recorded. Nevertheless, you're not shown by video, but just to let you know. And if you have questions throughout the tech talk or at the very end, we will have a quick discussion round where you can just share your questions. I will invite you to write them in the text box and I will just read them out loud so Angela can answer them briefly. And if not, we will also share her LinkedIn profile involved where she's very happy to answer your questions then after the tech talk as well if they're coming here. Yeah. That being said, I would say let's give the stage over to Angela to start with her tech talk on understanding customer needs with NLP. Thank you for being here, Angela.
Yeah, thank you very much for having me.
Great.
Share my slides now.
The stage is yours.
Okay. Okay, can you see my slides now? Okay.
Yes. they are there. Perfect.
Great. Yeah, thank you everyone for coming to my talk on understanding customer needs with natural language processing. In the next half hour, I would like to show you the potential of natural language processing in this domain and illustrate this using an example of a project I did at dida. So first of all, I would also like to introduce my company, dida. So we're a software company with 30 plus scientists, mostly mathematicians and physicists, and we're specialized in algorithmic problem solving and machine learning. We do both research projects as well as industry projects, and our goal is to bridge the gap between research and industry, and also proof of concept to production model. If you're interested in finding out more, this is our website, dida.do. And yeah, so this project I worked on, we worked together with a company called Thelmo. They offer veterinarian services directly at pet owners' homes. And this leads to reduced stress for the animals and pet owners. And what's also important to know in this context, that the appointments are booked online. And this is a startup operating in cities across Germany. So I decided to divide up this talk into 4 parts. The first one, I'll explain kind of the problem at hand. In the second part, I will talk about our approach to the problem. In the third part, it'll be more kind of details on our concrete solution. And in the end, I wanted to kind of illustrate the impact the solution had at Thelmo. So first to the problem. So the general problem we were dealing with here was a simple conflict of interests. Users don't want to be limited to predefined options, but for processing, structured data is often necessary. So another example of this problem is tests, correcting tests. I think we have all been in this situation where we maybe are forced to do a multiple choice test and think maybe A and B have some parts of it are correct and some are wrong, so we can't decide. And maybe these tests are not optimal, but they're easy to correct, and that's why they are made in such a way. So for processing, these predefined options are necessary. So let's look at the concrete example of this type of problem that occurred at Thelmo. So as I said, one can book these appointments online, and one sees this mask here when one tries to book an appointment. And one of the fields, or I guess one of the only fields, is the appointment reason. And the customers prefer to type in free-form text, but to be able to estimate the appointment duration, structured data is necessary. So structured data in forms of which services, what symptoms, what disease does the animal have. So to kind of show that this is a problem even more, or maybe first, what did Thelmo do up until now? So what they did is that they gave the users the option to put in free-form text, but showed these suggestions as the person was typing to encourage them to choose from these predefined options. So kind of as a first step in this solving this problem, we looked at the data and saw that only 1 in 4 people actually stick to the predefined options, and 3 in 4 also enter free-form text. So this also illustrates the strong preference of users to enter free-form text in this context. On the other hand, if we just allow free-form text and have no way of processing it, we might end up with wrong time estimation. So if we overestimate the time needed for an appointment, the vets have idle time, hence the costs go up. On the other hand, if we underestimate an appointment, the customers for the following appointment have to wait, and the vets might have to work overtime or wait to have a break. And this would lead to unhappy customers and unhappy employees. So yeah, I hope I was able to convince you that this is also a problem. There's no good time estimation. So this leads us to the approach or solving the problem. How can we do this with natural language processing? So maybe the naive way to approach this, or the first try, would to use a neural network and directly go from appointment to duration. The problem with this approach is that there's a lot of data needed, and especially with Felmo being a young startup, there's not enough data, but I guess also for a lot of other companies, this would be the case. There's really a lot of data needed to train a neural network to understand our language. So how can we, what is an alternative approach one can take using natural language processing? So if we go from appointment just to structured data, we can use, this is kind of a more general task where you only need language knowledge and not any veterinarian knowledge. And one can take a pre-trained neural network trained on lots of language data found on the internet and other places to train a neural network to get a general understanding of the German language, and then adapt this model to convert this free-form text into structured data. So structured data here are these different symptoms, diseases, or services that the customer wants. And then we still need to go to the duration, but going from the structured data to the duration, while Felmo doesn't have maybe enough data to create a model to go from structured data to duration, they have a lot of domain knowledge. They have experienced vets that know which services take how much time and which symptoms indicate which diseases. So this is why we decided to split up this process into 2 steps. And the first task was done by dida, as we have a lot of experience with natural language processing. And the second step was done by Felmo, since they have a lot of knowledge on veterinarian services. So in the rest of this talk, I will be focusing on this first step, but we should also keep the second step in mind. So to be able to use natural language processing for this step, we have to formulate it as a machine learning problem. For this, it's important to define what is the input, what is the expected output, and what metric do we want to optimize. So since machine learning problems are always optimization problems, this is also very important. So the input and output are quite straightforward. So the input is what the user types in, and the output are these predefined options or labels that Felmo had already created. It's probably also important to know how many data instances do we have. So in this project, we had a bit under 4,000 labeled appointment reasons available. This might not seem as such a small number, but if we also consider that there are 800 different predefined options or labels, you can see why I called this a small number. And if we also consider that there's not only one label per input, but can be up to 10 different labels, making this a much harder problem, this number of 4,000 data instances seems really small. So now to the metric. And here's the part where it's important to know what is the second step. For the second step, going from structured data to the duration, we didn't have a fixed model. Since Felmo was still developing this, but Felmo could tell us that predicting wrong symptoms is worse than detecting too few. So that's why we wanted a metric that weights false positive as more severe mistakes than false negatives. And this is actually exactly what an F0.5 score does. So this was kind of our go-to metric for this problem. Another point that was important to Felmo is that all instances should be weighted equally. So if we just take an F0.5 score, appointments with more labels could have more weight than appointments with few labels. And to avoid this, what we did was that we calculated the F0.5 score for each instance, each labeled appointment reason in our data set, and then averaged this. So this is illustrated here with a very small data set of only 2 examples, where for each example, the F0.5 score is calculated, and then these scores are averaged to get a score for the whole data set. Okay, so now, since we've identified our task and formulated this as a machine learning problem, we can go to the kind of solution to this machine learning problem. But as a first step, we wanted to define a baseline to compare our more complicated neural network approach to, and look that we're actually providing a benefit. So as our baseline, we used a fuzzy matching or edit distance approach, which are just using string operations. So not using any knowledge of the German language, but just looking at the different letters and comparing them. So I wanted to illustrate this approach using an example we've already seen. We have the input and the 2 correct labels. And then for each label, this algorithm would compare to the input and say how good is the score. So usually you would have to do this with all 800 labels, but I'll just illustrate this for these 2 examples. So for Handabsachtsbeschwerden, this occurs directly in this text. So we're looking for the closest substring, which is of the same length. So in this case, this is the string itself. And the edit ratio is 1 because we don't have to perform any edits. For the next one, it's not exactly in the sentence, but we have a part of this in the sentence, and this is the closest substring of the same length. And if one calculates the edit ratio, one gets a score of 0.5. Half of the characters have to be edited to get the same string. So then before one applies the algorithm, one sets a threshold, and this would be usually maybe something around 0.7, meaning that this first label is found, but the second label is not found. Okay, so now to kind of our approach. So if one doesn't use string operations, one usually has to kind of represent these appointment reasons or vectors or labels as vectors. And this is kind of illustrated here. So one can, this is called embedding, representing a text as a vector. One does this for the query or appointment reason, as well as for the labels. And then one can compare them using cosine similarity, so kind of a dot product, but normalized, to get scores for each of these labels, similar to the baseline. And what's important, and again, as shown with the baseline algorithm, one sets a threshold and any scores above the threshold counted as correct or labels, and the other ones are not fitting labels. So this cosine similarity is very quick to calculate, and these embeddings of the labels are synonyms since the labels don't change. One can pre-compute them, and that means one has some time to calculate an embedding for the appointment reason, and this is important to have this time if one wants to use a neural network, since this is compute intensive. Okay, so as I already indicated, we want to use a neural network, and in particular, a large language model. So just quick introduction on these. The concrete large language model that we used is BERT. So these are deep neural networks. In this case of BERT, or I guess also most large language models, have a transformer-based architecture. So this architecture has brought great improvements to the domain of natural language processing, and kind of this architecture, along with training these large neural networks in an unsupervised way, have brought significant improvements in the last 3 or 4 years. So these are trained with unsupervised or in an unsupervised way. And then what we used is called sentence BERT, and this is basically just this BERT, but you add some pooling layer, so one small layer without any trained weights, and then you train it or fine-tune it on a supervised training task, in particular here of predicting if two sentences are similar or not. So this is kind of sentence BERT, and we took some weights someone else had trained to use for our purposes here. So the sentence BERT can be used as an embedding, so to represent a text as a vector. And this fast text here is another way that doesn't use a neural network. It's also a type of embedding. And we just compared these kind of out-of-the-box sentence BERT and fast text to our baseline. And yeah, as you can see, the score is quite a bit lower, or was quite a bit lower. And this came as a surprise to us that, I mean, we didn't expect them to work well from the get-go, but not this badly. So we had a look at some of the examples to see what was going wrong. So one of our first observations was that users often input lists, and sentence BERT often seems to only encode one or a few of the fragments. So here is an example. These are kind of sentence fragments. Each of them is kind of unrelated to the next. They're not really sentence. They're not separated by periods, just by commas. And the scores that fit well to the first part have a high score. The labels that kind of fit also have a higher score though than those that fit well with the last part. So in this case, all labels that have to do with food had a high score, and this was a problem. So how did this come to be? So the reason is that the data in pre-training is different from the data that we had now. So when this model was trained, it was trained on headlines, captions, and forum text, which are all kind of short pieces of text, but they're information sparse text. Whereas now, in our task now, we have a list of up to 10 different symptoms, diseases, or services, which again is like a short sentence, or maybe not sentence, but short piece of text, but it's very information dense. Each one of these fragments is important to encode. So how can we solve this problem? And our solution was to split up this piece of text into fragments and then input each fragment into sentence BERT and then combine the results. A second observation we made was that sometimes labels were predicted, or two labels were predicted that we know can't both be true. So an example was eats a lot and eats little were both predicted, but yeah, we know that this can't both be true. So what is the reason? So again, this is kind of a difference in the task this model was trained on, where eats a lot and eats little are counted as similar sentences, but in our context, they exclude each other. So we introduced some post-processing to alleviate this problem. So kind of our recipe or our algorithm was that we first look at which labels are counted as similar for sentence BERT. And if two labels are similar, we do predict the score for both of them, but then we only keep the one with the higher score. In this case, eats little. So now, having implemented this pre and post processing to sentence BERT, we get quite a bit higher score. So we haven't reached our baseline yet, but are going in the right direction. So the next part is fine-tuning. So we want to further improve our neural network by training on this task. But the problem with the task we're working on right now is that we have to embed 800 different labels and a query. And as I said before, during prediction, this is not a problem because we can take our time to pre-compute 800 labels. But if we want to train, this is too much computation. So this would take too much time if we just train on this task. But what we can do instead is that we pick one of the labels and just predict if it fits to the query. So it's a simple classification, fits or doesn't fit. And in this case, we only have to calculate two embeddings, that of the label and that of the query. So here you can see our setup during fine-tuning. We have our query or appointment reason here. Here's the label that we sampled. Both are embedded using sentence BERT into vectors. The vectors are compared. And then we have a prediction of fit or no fit. We have a label if this pair fits or not. And this goes into our loss function, and then we can update the weights of our model. So a very important point of this fine-tuning is the sampling. So if we randomly sample our label, there would be on average 2 out of 800 labels which are correct. So in this case, the model would already perform really well if it said for every pair, oh, this doesn't fit. And the model would have trouble learning more than this naive rule. So we had to set a ratio of positive samples. So for example, we said, okay, sample 1 out of 5 sample labels should be correct. And then the model can learn a lot more. So with this fine-tuning, in addition to the pre and post processing, we were able to achieve a score of 0.75, which is not only higher than our previous score, but also significantly over our baseline. So this was a model that Felmo could work with and improve their time estimation. So here I have one more slide on the final results. These are precision recall curves, and they kind of give you more an idea of how well these different models perform. All of these small dots are points for different thresholds, and then these are connected for the different thresholds of the same model, and the points in black are those thresholds that are optimized to get a high F0.5 score. And on the one hand, we have the precision. So how many of those labeled found labels are correct? On the other hand, we have the recall. How many of the labels are found? So 1 is very good in both cases. So the more to the top and the more to the right your curve is, the better. So we hear that see that our default sentence bird performs the worst. The fast text model was a bit better, but kind of similar range. Then when we added the pre and post processing, it improved significantly over the default sentence bird. Then the red line is the base model, which is still a bit better than this sentence bird with pre and post processing. But when we also did the fine tuning, we improved greatly, not only for the F0.5 score, but also for for other criteria. Okay, so in conclusion, fine-tuning a large language model on a small data set actually works. So large language models can not only be used for big companies, but also startups like Felmo. And the second point is that further adaptation of a model can lead to big improvements. So you don't have to give up when the out-of-the-box version doesn't work. So now to the final part of the presentation, the impact for Felmo. So I showed you the website of Felmo, and one can ask what changed here. But the answer is nothing changed. If we would remove this suggestion function, we would cause the users to change what they input and cause a so-called data drift. And also some people might appreciate these suggestions and prefer using these predefined options as well. On the other hand, what changed in the background? So I was talking about that this time estimation impacts, for example, the vets. And now with this data processing, it's possible to improve the scheduling through better time estimation. And it's also possible to identify appointments requiring special equipment, which again improves the scheduling. Yeah, thank you very much for your attention. If you have any further questions, I think now we have some time planned to answer questions, but also feel free to write me an email or to write me via LinkedIn. And you can also find out more about dida on our website.
Thank you very much, Angela. That was really interesting and really inspiring as well. Questions are popping in the chat box, and I hope we have time to answer all of them. If not, we will just reach out to them later, or I mean, you will see them. In order to give the others the time to write some more questions, let me just ask a very brief, quick questions. We know that ChatGPT is now all over the news, and I'm super, excited to ask you this question of you use SentenceBird right now. How is that like different, or would have been different in your project if you would have used GPT-3 or ChatGPT?
Yeah, thank you for the question. Yeah. So with the ChatGPT-3 or GPT-3, there are much bigger models. So the SentenceBird, it has around 100 million parameters, but this ChatGPT-3 has around 100 billion, so a factor 1,000 times bigger. And as far as I know, it's like not available online, and it's very compute intensive and not feasible to run you need very different infrastructure to host it, and especially to train it. And even for the SentenceBird, I think the estimate is around 500,000 to train one. But if you have one available online, you can fine tune it for your purposes. And this is maybe also a difference with the SentenceBird. You fine tune them for your purposes, whereas this GPT-3, it's so big and trained on so much data, you usually don't have to fine tune it anymore, but you have to kind of engineer your prompts instead. But it's also not as available to everyone as this SentenceBird, which you can,
All right. Thank you. Yeah, let's see what the future brings to all of us, right? I mean, I know that the media is full of them working on it. Some questions from the audience. Mohsen Ahmadi Fahanda, I hope I pronounced it correctly, asked 4 questions. I will make it to 2 questions in order to give the others some time. The first one is, how long did this project take you? And then a more specific question would be, did you try to use contrastive loss? If not, why?
Yeah, thank you for the question. So in this project was only around a month. I was working on it, and I contrastive loss. So I didn't use the contrastive loss in this case. I think this would be something I would have tried out next, but since it was only for it only took 1 month, the project, and the customers were happy with the results. It ended there.
Sure, thank you. Acharya Prabhakar, sorry if I pronounced it or mispronounced it, asked an interesting question on the vocabulary itself and SentenceBird. So medical vocabulary in German has a lot of Latin influence. Does that create a problem while applying models like BERT that are pre-trained on generic German data?
Yeah, so good question. I guess I'm assuming that even these German models have seen some Latin or some medical terms, but it's definitely a problem. But I think especially in this case, that the customers probably usually don't use this Latin vocabulary, and these predefined options sometimes use this Latin vocabulary, but Thelma also provided us with some synonyms that are maybe more commonly understood, and this definitely helped.
Yeah, I think that exemplifies how important it is in such project to really work closely, right? With your client in there. On the business side, Hubertus von Rönne asked a question, how many people from dida worked on this project? And also, what are approximately costs for such a project? I don't know whether you know them or you're allowed to ask in that, but I mean, just give us an idea if you will.
Yeah, I'm actually not so deep in the maybe cost side, but as for the people working on this project, so this was a smaller project where I was mainly doing the coding, and a colleague was maybe doing 1 day per week, just reviewing my code. So it was quite, yeah, a smaller, less expensive project.
All right, good. I mean, probably also some details can be asked to you via email then or so to update that. Well, thank you. And Walter Koch asked another question. He asked, do you have numbers comparing the estimation times before and after you realized the project? Remember, duration was one of the things. It's probably related to that.
Okay. So the estimation of for the vet, or yeah, I actually don't have these numbers. This is kind of fellow internal information that I do not have.
All right. And Tina Simic asked, do you work with a knowledge graph in this case?
No, in this case, I didn't use a knowledge graph. We had some synonyms for these labels and just kind of use them as different labels, but then it didn't matter which label the model predicted, if it predicted one or another synonym.
All right, and another question from Dr. Martin Riedler. He said, thank you for the nice presentation, which I agree with. Is there a reason why your fuzzy matching baseline, which kind of worked okayish, as you said, was not also incorporated, for example, feature and dimension into your neural network-based approach?
Yeah, thank you for the question. So yeah, it's a good question. We actually tried out incorporating this. So in the beginning, so it was actually that we first fine-tuned the model and afterwards added these pre and post processing. But after just doing the fine-tuning, our model wasn't that good, and including this fuzzy matching features actually helped, but in the end, it didn't improve our model. So it was better, or the scores were better without including these other features.
All right, thank you. Again, we get a lot of feedback on like nice presentations from the audience. I think I will take over from here and give you some last information. The one is taking up exactly from what Mohsen asked. Will the slides be shared? And I have a better solution for you. These slides and this talk will be uploaded on YouTube. I think it will be uploaded next week, so you can rewatch it, really go deeper down. And listen to Angela again explaining the details of the project. We will keep you posted, so you can just you will find the information on our website. We will probably also post them on our LinkedIn. So subscribe to that channel and stay up to date. Then you can rewatch it. And we have another good news, and that is tonight we're gonna host an ML Stammtisch event, so a meetup at our premise in Berlin. If you are in Berlin, you can sign up for that event and meet Angela in person and ask all the questions that you still have to her personally. That being said, let me give you some more closing remarks, and then we will have probably a lunch break for you, depending on where you're staying. The first one is the upcoming events at KI Parks. We regularly host tech talks like these. The next one events that we are hosting is first a meetup. As I said today, it's gonna be at the KI Park office. There is an Eventbrite link posted or will be posted into this chat. So just feel free to register and then step by. It's going to be beers, pretzels, and cool ML talks. A lot of experts coming to discuss just your projects, and also if you are a developer yourself, get some more ideas. So it's very cool. If you want to learn more about AI Park, actually I'm holding another intro presentation, a more dense one about KI Park at the German-Swedish Chamber of Commerce, which will also be streamed online, and you have the opportunity to register here and just get to know more about KI Park. Then there is a startup breakfast. So if you're a founder or if you work in a startup, we are hosting together with Keats a startup breakfast. All the news, it's going to be spread. If you're asking yourself why there are these little hearts, it's on Valentine's Day and it's going to be a Valentine's edition. So be prepared for some cheesy Valentine stuff. And then there's another tech talk coming up already end of February on quantum technologies, and there's also probably another one going to be in like beginning of March and maybe also in February on synthetic data. So more cool stuff to talk about, more recent developments, and more opportunities to get inspired. If you want to attend to these events, I think there are two main important sources. The first one is our newsletter. You can just use your cell phone to scan the QR code, and then you're getting directly redirected to subscribing to that newsletter if you haven't. This is probably our main source. It's going to be in English, it's going to be in German, and we are going to update you on all the events that we're having and everything news from our ecosystem. And also, if you want to learn more about KI Park, visit our website, subscribe to our LinkedIn, where we're posting a lot of cool stuff going on in the AI tech scene. And also the membership is there if you want to support us, if you want to be part of that ecosystem, if you want to reap the benefits that I described at the beginning. Become a member, be updated, and use that QR code in order to get some further notifications. Yeah. And finally, if you have questions right after the talk, feel free to shoot me a message. You can reach me on mark@kipark.de. You can find me on LinkedIn as well. I'm happy to answer your questions. And I hope to see most of you, some of you tonight at the Stammtisch event. I'm going to be there. I'm going to be there too. Angela is going to be there as well. And we are very happy to welcome you and discuss some more details on AI and all the topics in there. Cool. That being said, thank you all very much. Have a great lunch break. And I hope to see some of you, most of you, soon in our next Tech Talks. Angela, the last words are for you.
Thank you very much for having me, and I look forward to seeing you this evening.
Great. Bye-bye. Take care all.
Bye.
Thank you.